Hey everyone, I'm John from Nichathan Gaming, and today I want to lead you through the basics of a connect the dots game. Now, we are not going to be making this actual one. This is one that I have in production, but I can still show you the gist of it. So we have our game here. It will highlight things, you will connect it. There we go. We can easily get a move counter, and there you go, you have the puzzle. And so I'm going to walk you through the code to get this and a basic screen layout that I have, because one of the things that we are using is we're using the code from another video of mine, which I will post along with this, which allows you to keep the grid the same size no matter what size your screen is. So if I have my screen this big, the grid is the same size. And if I have it this small, the grid is still the same size. And what we're actually using, as you can see over in my hierarchy, is we are using a 2D sprite renderer grid that is off of our actual canvas. Now, I do have a video on this where we use this to have a camera that does not change size, and then we add that to our canvas with a raw image and a texture, but I have not actually shown how to get the mouse input to work along with it. So without further ado, let's just hop right into it. Okay. So I'm going to drag over my favorite playground, and in my playground, that's where we will be looking at all of the different scripts that we need. So let me go back, let me create a new folder. I will call this the Pathfinder or Connect the Dots, whatever you wish to call yours. I will also start in a completely new scene. So at this time in your Unity, you should have an empty project. You should have a new scene open, whether that's the base scene or not, it doesn't matter. And I am using the Android build, but that does not actually matter. But I will be using a 16:9 portrait. On my camera, I'm going to have it set to a solid color with the background of 70 all around, so it's a nice gray. And we have a few things that we want. So I will walk you through how to create the normal game, and you can do many things after that. But okay, so now I'll right click, create a folder, and this will be for the scripts. And the first thing we want is we want a script that is able to control our game. So I'll right click and create a C# script. I will call this the static game controller. There we go. So this script will allow us to connect our scenes together. This is how you can move from the set up scene to the play scene and still have everything work. Let me zoom in a little bit so you can see my code better. And yes, we do want to extend from mono behavior. We'll be adding some TMP pros and some UI later, but we can have that automatically added. So the first thing is we want a static width that is accessible from every other class. And instead of using public, I like to use internal, which is like a public within your game kind of thing. You can read up more on the different public, private, static, protected, um, internal, and then I believe there's also a protected internal as well that gives a bit more um, usability. But yes, I will include a link to that because I do find that interesting. I'll give the width a default of 6. You could have this show up on game start. It will also have a height of 6. We'll have a random seed and then a Boolean value of if we use the random seed. So let's do an internal static bool, which I will call has random seed, and I will set this to false by default. I will also have an internal static int of the random seed that we want to use, which, we can give it a fun value of 42 or so. Okay, now we want a few variables that we will use to add to this scene. So the first thing I want is I want a slider. We'll do control period, and we'll add the using Unity Engine UI, which you can see added to the top. Now my slider, I will call it the width slider, and we will use this in a scene to control our width. I'll rename another one to be the height slider. Then we want a few TMP texts to display these values. So I'll say TMP underscore TEXT control period, and then I will add using TMP Pro. Now if you don't want to press control period, you can also right click and go to quick actions and refactoring, or if you hover over and click on the light. So many ways for you to add it there. And I will call this the width value, and I hope you guessed it that our next one is going to be the height value. Okay, now we also want a thing for our has random seed checkbox, so we will be creating a checkbox here. So I'll call it the image, and for this it will take another serialized field, and this will be actually with this I don't want to use outside assets, so I will have some colors instead. So I will have color checked. No, we'll just use the base green and whatnot. Okay, so we have the image, but now we also want an input field. So I will say TMP there we go, TMP input field, and this will be the random seed input field. There we go. Okay, now we are ready to start on our functions. So we will need functions to control the sliders, we'll need functions to control the image on click, and we'll need a function to control the random seed edit, so we can get these values from our scene. But first, let's create a start function where I will say the width slider dot value is equal to the width. The height slider dot value is equal to the height. We want to say that the width value is dot text is equal to an empty string plus the width, and then we have the height value dot text is equal to an empty string plus the height. Okay, we also want to say that our image dot color is equal to has random seed question mark. Does it have the random seed? If it does, then we want it to be green. So we will say color.green. Otherwise, if it does not have the random seed, then we want it to be color.red. There we go. And we also want to say that the random seed input field dot text is equal to the random seed, and we can't just do random seed, so let's do quotation marks plus. Okay. So let's add a quick comment to this where it initializes the display values, or sets the display values. Okay. We can also give a comment up here. So a typical static game controller holds the values for the game. Okay. And here, let's even give some headers over here so we can see it in editor. So we will say set the width, set the height, controls the random seed. Okay, so now let's add our first function. So I want this to be public since I will be assigning it in editor. So it will be a public void on width change, which will take a float of f, because sliders, even if you set them to integer values, will only return floats. At least that's what I see in my experience. And we will pretty much just add what we had here. So we want to say the width slider dot value. Well, we don't really need to say the width slider dot value, but we do need to say the width value dot text is equal to f, but not just f. So let's go over here and say the width equals casting to an integer f, and then we can say width, which will be cast to an integer. F should always be a whole number, but for some magical unicorn reason why f comes out as 1.01, we still want to round it down to 1 set to width. So our width value is never going to say you have a grid width of 1.1, because you can't have a grid of 1.1. Okay, let's just copy that whole thing, and instead of on width change, it's going to be on height change. Then we need to change width to height. Let's copy this, because instead of width value, it's going to be height value, and instead of width, it's going to be height. Okay, make sure that you have those changes. So let's say runs when the slider is dragged, the new width value dash 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 runs when the slider is dragged, and then we'll call this the new height value. Let's collapse these, and let's go down here, and we want a public void toggle random seed. And what this will do is it will toggle the random seed has random seed checkbox. Now you can upgrade this by setting the sprites and the color on click, but we will just be using the colors right now because I don't want to have to worry about too many assets. So, okay, I will say the has random seed equals not has random seed, so flip the Boolean value. If it's true, it becomes false. If it's false, it becomes true. Then I want to say that the image.color, and we can just rip this straight out of here. So our image color, if it has random seed, is now green, otherwise it's red. And that's a very basic way to add a checkbox to your scene. Then let's go public void and let's say on random seed change. And it will take a string value. So for our random seed, because it can be anything from negative 100 billion to positive 100 billion, whatever the size of the integer value is, we do want to allow that input in the string. Okay, so to give a quick quick description of what this does is it changes the random seed value when the random seed input field is changed. And the value is the new random seed. If value is in error, set as blank and return value to base. Okay, so you could go up here technically and do something like an int base random seed equals 42, and maybe that's even a better practice, so I'll do that. And then I'll go down here and let's create a try catch. So we have a try and we're just going to catch an exception, which we will need to add the system.exception. And we're not going to actually grab any of the values because we don't really care, but we will say the random seed input field dot text is equal to nothing. It now has no text, so it will show our placeholder, and we want to set our random seed to be equal to our base random seed. Or if you do not have base random seed, then just set it to 42. And what we will do in the try value, the thing that will throw the exception, is we will say that the random seed is equal to the int dot parse the string value. So we will try to turn value into an integer number and set it to random seed. If this does not work, then we will go back to the base. The only time this will not work is if value is empty, because we will be setting that explicitly. But okay, now we have our static game controller, and this will help us control our static game. Now the next thing we want to do is we want to have a thing called a cell. So a cell will be a single piece of the game. So I will type public class cell, and let's also extend from mono behavior, and then I'm just going to press Control period. Let me see, maybe inside. Yes, Control period, and I will move it to a new script, so it will create its own script. And then let's see if I can find it. Golly. Maybe in my editor. There we go. Looking at the wrong area. Too many scripts tossed together in this. We do want our... No, this is fine. This is fine. Okay. So the first thing we want is a description. So a typical cell controls a single point on our game grid. Okay, so I will say the internal int x and y. I also want a previous and post, so I'll say internal cell previous comma post. So this will create a linking. We also want an internal byte for the type index. You'll have an internal color, which I will call type, and then it needs a few Boolean values. So let's add an internal bool is head, comma, is selected. Okay. Then let's add some serialized fields, some sprite renderer components that we can grab. So I will say serialize field of the sprite renderer, and I will call this one the outline. I will copy this about 5 times. The next one is going to be the head. Then this one will be the glow. This one will be the previous bar. And this one will be the post bar. Let me double check and see that that's all we need. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, we'll delete that last one. And finally we want a, not finally, but next we want a color, which will be our base outline color, and I like to use a gray. I believe this gray is about 150, 150, 150, but because we are doing this in script, it must be between 0 and 1, which means do 150 divided by 255, which gives you a 0.5882353F. Let's just copy that because we will have it 3 times because we're using a gray value. And then the last thing we want, I will actually add it up by this cell. I will say internal line. Now make sure that it doesn't add this nonsense like this one did, or it decides to say what you want without you clicking it. And we don't have a line class yet, so that will throw an issue. So let's kind of create these almost simultaneously. So I'll say public class line, and let me just triply double check. Do we want our line? No, we don't need our line to extend mono behavior. Okay, and I will press Control period, and I will move it to line.cs. Okay, now we have our line. I can even open that up. And now let's go back to our cell, and we'll add functions to line as we need them. So the first thing we want is we want to be able to initialize our cell. Actually, I'm not sure. I don't think we actually ever initialize our cell. We'll come back and add the initialization if we do. But what I definitely do is I set it, I believe. No. Okay. Let me go through and look at my script just so I know what we do. So let me place images is where we go. And yes, so we do actually initialize our cells. That's great. I don't want to add any extra code that is not needed. So I will say internal void initialize, and this will just take an int. I really hate when it does that. Initialize, and it will take an integer x and an integer y. Okay, and we will just say this dot x equals x, this dot y equals y. We will say that the type index is equal to, you know what, let's set these defaults here. So our type index is equal to 0, our color is equal to color.white, our isHead is equal to false, our isSelected is equal to false, our line is equal to null, which it should be by default, but sure, let's just toss it in anyways, and that's equal to null, and that's equal to null. Okay, so the only thing we will actually be assigning is the x and y with our initialize. Then let's have this next part is still under development and it's not necessary, so I won't be adding it, so we can actually delete the outline because I'm still working on that code for my own special purposes. So I will leave that out, but you can add an outline with a color and then color the outline when it's highlighted, but I won't be guiding you through that. So our first thing will be telling us if it is connected. So I will say an internal Boolean function of is connected, and it will take a cell and tell you if it is connected. And so I will say if cell dot equals this, and we will be overriding the equals function later, I will say return true. Then I say if the previous doesn't equal null, then I need to say return the previous dot is connected to cell. Otherwise, it will return false. So what this does is we have a string of cells, and you say to this cell, are you connected to cell A? Now cell F says, well, no, I'm not cell A. Look at my parent, the one before me. Cell E says, no, I'm not cell A. Look at the one before me. Cell D says, no, I'm not cell A. Cell C, cell B, and then finally cell A will say, well, yes, I am cell A. Return true, and it returns true back through the whole loop all the way back to cell F. Now, if cell A is not there, it stops at cell B, then it will get to cell B. Cell B says, no, I'm not, and there's nothing else behind me. And it will return false all the way through. So let's give that in a comment. So it checks this, and all parents as being equal to cell. The cell that we are getting is going to be the object to check against, and it will return true if Okay, and for the initialize, we just want to say sets the x and y. So let's say horizontal position, and this y would be the vertical position. Okay, so now we have a few good comments going after is connected. We want to be able to unset it. So let's have an internal void called unset. And what this does is it unsets this object or removes it from a line of cells. And we do want quite a bit here. So let's say that it will say if the post is not equal to null, then it will say post dot unset. Then it will say if the line is not equal to null, it will say line dot. Okay, and here we do need to go into our line real fast to add a few variables. The main thing we want is we want an internal cell of head A, comma, head B, and then we also want an active cell. Oh, and we go back to the cell now. So the line dot active cell, and let me go back to my cell so I can see what I want to do. And I will say that the active cell is equal to the previous cell. Then I will say if it is not is head, so we don't want to run these next commands if this is a head. We will say that the type index is equal to 0, and we will say that the line is equal to null. So if you are a head, you will always have the same type index, the same type color, and the same line. We can also say that the type is equal to color white. Okay, and that's if it is not is head. We'll also say is selected is now false. And finally we say if previous doesn't equal null, then we want to say that the previous cell dot, and just because we don't have this yet, let's add an internal void of set post of cell post this dot post equals post. We'll come back later to finish this off, but okay, previous dot set post to null, and then we will say that the previous is now null. And then let's also do this where we have an not internal, we just need a void of set images, and we'll come and add code to that later. So after our is previous null, we will say set images. Okay, so here's our unset. We say if the post is not null, then we need to unset the post. If the line is not null, then we need to set the line's active cell to our previous cell. If the head is not null, then we need to say that the head is white, index of 0, and line is null. And perhaps I even want an else in here. But oh, if is selected as false, previous is not null, then set the previous to null and previous now equals null, and set images. Okay. So that's all we want for our unset function. So let's go into a few setters now. So this goes on top of initialize. So initialize is just for setting the x and y, but our setters are for setting the parent line. So I will say internal void set, and I believe I want both of these. Yes, I believe so. So I will say set, let's take a byte of type index, a color of type, a Boolean value of is head, and then a line of the connected line. And at the very bottom we will say set images. Now above it we just need a lot of thises, so we say this dot type index equals type index, this dot type equals type, this dot is head equals is head, this dot line equals line. Okay, so that's our first step, but we do want to copy it and we'll paste it over here because we will want to remove the head. So just delete the head and then we'll remove that there. And let's give it a description. So this will set the values for this cell and this type index, this color, is it a head, the connected line, and let me just copy this summary that I made. I'll paste it here and I will remove the head again. Okay, so those are our setting values. We do want an internal void for set selected, which will show that this is actually selected. So I will say is selected equals true, and then I will say set images. Okay. After set selected, we want set post and set previous. So set post, I will say if doesn't equals post. So if this is not the post cell, because we don't want to allow it to be equal to itself, then we say this dot post equals post, and we will also want to set the images. So we have lots of times when we're setting our images. And we can, pretty much copy this and then paste it, and then instead of post we will say previous, and then cell post is going to be previous. Let's copy that, previous, and then I will say is selected is equal to previous doesn't equal null. So if the previous is not null, then it has been selected. Okay, now finally the one that we've been looking at quite a lot is our set images. So let's make another void of set colors. This will set the colors on all of our images. And so we will say set colors. Oh, I'm terribly sorry. We need that. Okay. So we'll set the colors. Then we want to say that the head.gameObject.setActive is true if it is head. We will say that the previous bar.gameObject.setActive is true if the previous does not equal null. We will say that the post bar.gameObject.setActive if the post does not equal null. And we will say that the glow.gameObject.setActive if is selected. Okay, now, so here this will display the images of this cell, or not images, I will say the sprite renderers of this cell based on the values present. Also, oh, we forgot a few of these, so sets this as selected, sets the cell that comes after this parameter name post. The new post cell. Okay, set previous, sets the cell that comes before this, and then this would be the new previous cell. Okay, now let's go down at the bottom of our set images. We'll type #region, and let's give it the description of set bar rotations, and we'll say 90 degrees equals right. And then let's do #in_region. Okay, so the first thing we want to say is if the previous is not equal to null. So do we have a previous? Then we will say the previous bar.transform.rotation equals the quaternion identity. So set it back to a rotation of 0. We also want to have a getDirection function, which we will be getDirection is fairly simple, so let's do that. Let's have an integer of getDirection. This will take an integer of x0, an integer of y0, an integer of x1, and an integer of y1. So first, we'll have it return -1. Then above it, we say if x0 is equal to x1, so the x's are equal, and y0 is less than y1. Then it will return 0, which is down. And then let's just copy this whole thing. So, but this time if y1 is greater. And in this case, it will be not down, but up, and we will return 2. Over here, we need to change it up a little bit. We will say if x0 is less than x1, and y0 is equal to y1, then we will return 1 because it is right. Let's copy this and let's paste it here, and instead of less than, we will say greater than, and we will return 3 because this is left. Okay, so pretty much if the x's are the same and the first one, this current one, is less than the other one, then it's facing down. If the x is less, then it's to the right, then down, then left, like that. So let's apply it here. So back here, previous bar transform rotation is equal to the quaternion identity. We will say that the int direction is equal to get direction of x comma y comma previous dot x and previous dot y. Then if direction is greater than 0, else. So, oh, sorry. If the direction is less than 0, then this is, we have an issue. So I will just say that the previous dot set post to null. I will say that the previous equals null, and the previous bar dot game object dot set active should be false, because obviously the previous that we have selected is not actually previous. Okay, and then otherwise we'll say the previous bar dot transform dot rotate will rotate around a new vector 3 of 0, 0, and then the direction times 90. So 90 would be the rotation amount. We want to copy this because we are pretty much changing previous to post. So if post doesn't equal null, the post bar dot transform dot rotation is equal to quaternion identity. We get the direction of x, y, post y. Direction is less than 0, then post set null. Post dot set previous. Should be post set previous. Okay, and then this will be not post, but the post bar dot game object dot set active false, and then the post bar transform rotate, and there you have it. So let me double check. Yes, we do have quite a few things, but that was the end of our big set images. Our get directions will return the direction that a bar should be facing. And I'm just going to leave those values blank. Now for set colors, changes the colors of all of our images. Okay, so we say head.color equals type previous bar.color equals type post bar.color equals type, and the glow.color equals type. Okay, now let's add a few overrides and an on-trigger inter. So I will do control period, and I want to generate equals and get hash code. The equals, let me actually cancel this, control period, let me generate equals. And I just want the equals to capture the x and y. So let me deselect all, and then I will select x and y. So if this object is a cell and it equals the object and the x and the y are equal as well. That's all we really care about with the equals. And so I will say checks if the x and y of this object match. However, because we generate equals, we are also asked to generate the hash code. Right here we see the warning, it overrides the equals but does not override the hash code. So let's generate our get hash code, and sure, it can do whatever it wants. For those that are throwing an error, I'm just going to delete them. And you know what, let's just add the, oh well, I'll let it do whatever it wants. But our final thing, you know what, let's just return the base.getHash code. I like that better. Returns the hash code. Okay, and we do have one final thing, which is going to be an on-trigger inter. Now what this says is it will go to our game controller and it will change the current cell. So we don't have a game controller, but let's create it. So let's say public class game controller, and we do want this to extend from mono behavior. Control period, move the type to gamecontroller.cs. Let's open it up, and our first thing that we want to do is we want to say an internal static game controller instance. Then in our awake, I want to say the instance equals this. Then I will say internal void change current cell cell, it will do nothing yet, but we do want it over here, so we can say game controller.instance.change current cell, and we'll pass in this. So this is ran when our mouse is over this object and we are holding down the fire 1 button, which is also known as the left mouse button. Okay, now that's the end of our cell. So let's move on to our line next, which we have not as much to add, thankfully. So our line has 3 cells, the head A, head B, and the active one. It will also have an internal byte known as the type index. As we saw, it's going to have an internal color known as the type, and we want to initialize it. Okay, looks like we need to add Unity engine to access our color. Okay, so now let's have an internal void initialize, which will take a cell head A, cell head B, a color type, and a byte of type index. Okay, now to actually start initializing this, we just need to say this dot head A equals head A. This dot head B is equal to head B. This dot type is equal to type. This dot type index is equal to type index. And finally, let's say head A dot set, and it will take a type index, type, and this. Let's copy and paste this and change it from head A to head B. And that's all we need for our initialize. So we will say initializes the values in this line. Okay, let's now create an add function. So let's do internal void add a cell. So what this does is it adds a cell to this line. So what we want to do is we want to say if the cell dot type index is not equal to 0 and the cell dot type index is not equal to this type index. So for this we will say this cell is part of another line. Destroy that line first. Okay, so we will say cell dot unset and we will say that we want to just rerun this function. So we'll say add cell. Okay, now let's close this. We will say set the head of the line. So we'll say else if the active cell equals null, then we'll say if cell dot is head, then we will say cell dot set selected. We will say that the active cell is equal to the cell, and we will say, and that's all we will say. Okay. Then let's have one final thing. We want else, and this would be add a new cell to this line. So else we want to say if the active cell dot is connected to this cell and the cell is head. We will say if the cell dot post doesn't equal nothing or null, then we want to say cell dot post dot unset. Okay, next let's say cell dot set selected and set the active cell to be equal to this cell. Then let's go below this. Let's say if the cell dot type index is equal to type index and the cell is not a head, or if not cell is head. So this means we have this cell in the here, so we've looped around to the head of the line. We have this cell in the line and we want to move back to it, or we want to undo the line until we get back to it. Okay, so if the cell type index is this type index but the cell is not a head, then we want to say if the cell dot post is not equal to null, because there will be a slim chance that we can access the same cell twice, which would throw an error. We will say cell dot post dot unset. Else, otherwise, this cell is not a part of this line or other lines added. So otherwise we say the cell dot set with the type index, the type and we want to say that the active cell dot set post will be this cell. We want to say this cell dot set previous will be the active cell. We want to say the new active cell is now equal to cell. And we want to create an input handler to take some input here. So let me do a public class input handler, and we will say, so we want another instance, which means we want to extend from mono behavior, so we will say internal static input handler instance. Then on awake we will say instance equals this, and then down here we will say internal, let me scroll down for you, internal void cancel click control period. Oh, let's go to the top, control period, and let's move the type to input handler CS. Okay, now finally at the bottom of this we'll say if it is oh yeah, okay, we need to create that Boolean value. So down here let's say internal bool is connected. For now we're just going to return false, and then here we say if is connected, then we want the input handler dot instance dot cancel click, which we will program later. Okay, so let's go and let's close down our ad, and let's look at our is connected. So this determines if head A is connected to head B. True if connected. Okay, so for our is connected, it's actually very simple. So we say if head A dot is connected to head B, or head B dot is connected to head A. So if either of the heads is connected to the other one, then it will be true. Let's also have an internal void of, do we actually use clear to, let me control KC because I don't think I'm actually using that in the line. Let's go all the way back to here. Let's compile some scripts because I don't want to have us add scripts or code that is unneeded. Okay, yeah, so we aren't actually using that, but we might be using clear. Control KC, save it, and go back. Let me reload these scripts. Okay, great. So we are actually using the clear method. Control KU, save it. So let's do an internal void of clear, and this empties this line. So it will say if head A dot post doesn't equal null, then head A dot unset. And let's copy and paste this, and we'll just change head A to head B the second time around. Okay, so that's our line. The next thing we want is, let's go into our main function. So let's go to our grid generator. We don't actually have a grid generator yet, so let's type public class grid generator, which will extend from mono behavior, and we'll type control period and move it to a grid generator script. Now let's open the grid generator, and let's say we have a serialize field. So here, a typical grid generator generates the Pathfinder grid. Generates and displays. So this is the meat of what we are going to be, or what we are working on. So the first thing is it will take a game object of a cell prefab, and it will take a serialized field of a transform of an instantiation location. There we go. It will also take a serialized field of a camera named game camera, and it will hold a system.random called random. It will have an internal static float of the vertical mouse move multiplier, which we are setting to 0. Let's copy and paste it, and instead of vert, we'll say horizontal, or horiz. Then we want a list of vector2 ints for our walk. So let's say list, we need to add our systems collections generic list, and we want vector2 int, which we'll call our walks, and we'll say this is equal to a new list vector2 int. Okay, let's have a list of color, which we'll call available colors, and it will equal a new list of color. We also want to have a color array called colors, which we'll say equals to a new color array. And I have prepared about 30 unique enough colors for us to use. Feel free to use them as well. You'll just have to type it in by hand, as I did when I created this list. Here's the list. Pause it here if you want to use them. Okay, and we're continuing on. The next thing we want is we want a byte grid, or sorry, a multi-dimensional byte array. So we'll say byte grid, and this is going to be equal to a new byte, which will take our static game controller dot width and our static game controller dot height. Then we want a transform, a multi-dimensional transform array of our new images, and this will equal, let me just double check that we actually want this here. No, so I don't think we actually want or need that here for these purposes. Yeah. Oh well, we'll add it here and we'll move it later. And it's pretty much going to be the same as this, but we need to change byte to transform. And we will remove it, or we will not remove it, but we will move it later. Okay, so now in our start function, we want to say that our available colors will have the added range of our colors. We also have some magical math that I spent a long time working on, where we'll set the camera size to 1.2f times the static game controller dot width is greater than the static game controller dot height. If it is, then we want to say static game controller dot width, otherwise static game controller dot height, and this will all be added to 0.08f, and then I want to multiply that by 1.01f. So what this does, is it will set the size of our camera to just be outside of the size of our grid. And this uses quite a lot of calculus or trigonometry or something like that to calculate the size. Pretty much everything that I learned went into it. So yeah, if you have extra questions on how I came up with these values, I might be motivated to make a video talking about how to do the math there. But then we want to say that the game camera orthographic size is equal to the camera size. We also want to say that the vertical mouse move multiplier is equal to, this was some more math that was much more complicated than the previous one, so 0.0005f, and this will be multiplied by the camera size times camera size, so you might recognize this as a y equals ax squared plus bx plus c equation, which is exactly what it is. So plus parentheses 0.405f times camera size plus 0.01f, and then I like to multiply everything by times 1.2f. And I believe this final multiplication here is to move it up, perhaps not. Okay, and our horizontal is going to be the same exact thing. So let me just copy and paste, and instead of vertical we are going to say horizontal. Okay. Oh, is there something wrong with my camera size? Oh, not orthographic, but orthographic size. Okay, now under this, we want to add a special function so we are always using a random seed. That way, when we want to find out what is going on in our game, we can recreate any level. So, what we'll say is we'll say if static game controller, and of course you don't have to follow this exactly, dot has random seed, then I want to say that the random is equal to a new system.random, which will take the static game controller dot random seed. Let's copy this, let's type else, let's paste it in, let me scroll down so you can see better, and we'll say that let's actually paste it one more time, but we will remove the random seed, so the random equals a new system dot random. Then I say static game controller dot random seed equals random dot next. So what this is saying is we are creating a random seed to use. Okay, and then we say game controller dot instance, and we want to set the level title text, but we don't have that in our game controller. So let's go back to the game controller script and let's add an internal void of, actually no, let's leave this out. So no need for this script. Okay, but we do want to then do this. Let's say void generate locations, and then void place images. So here at the bottom, the last thing we say is we are going to say that we want to generate locations and we want to place images. Okay, so now our start is done, and what this does is it initializes the grid. Okay, so after start, let's actually go into our update. Before that, let's go below place images, and I will call a void print grid, which will do nothing, but we will be using this soon. So let's type update, and let's say if I will be using p for this, input dot get key down is p, then I want it to print the static game controller dot random seed, so I know what seed it's using, and then I want to say print grid. Okay, and that's all the update is for. It's for debugging purposes, so I would even add that for debugging purposes only. Okay, after that, we'll come back up to the reset game. Okay, so let's generate our locations. So here we'll say hashtag or # region, and I will say initialize the grid. So let me just copy this, and then let's delete that, and then let's paste it here. So the grid equals the byte static height, and then we want to set all values to 0. So I will say for int I equals 0, I is less than the static game controller dot width I plus plus. For int j equals 0, j is less than the static game controller dot height j plus plus. Then I will say that the grid at I comma j is equal to 0. And below this I will say hashtag or # end region. Okay, let's go below that, and I will create an integer for the walk times. So how far does our crawler walk? Now this will be using a type of random maze generator that I talked about in a previous video. So you can watch that if you want more information on what this does, but we'll set it to equal a static game controller dot width is less than or is greater than the static game controller dot height, and we just want to say question mark dot width else dot height. So it will walk the number of times of the longest edge, which you will see in action very soon. Next, let's say k. So int, or let's say, yeah, just k, or walk index. Let's go with that. The walk index is equal to 0. Then I want a vector to int question mark because we want this nullable, and we want it to be called the start position, and I will say that this is equal to a new vector to int of random dot next of 0 comma static game controller dot width comma random dot next of 0 to the static game controller dot height. Now we want a while loop, so I will say while the start position dot has value, while it is not null, I will say that we want to create a new list of vector2 ints for walk. So this will be the first part of walks, or a single part of walks. So let's say list vector2 int walk is equal to a new list. So initialize the list. Then we want to say if the so we'll actually never be in that position. Okay, great. So let's add another function that would be count empty square neighbors. So let's go and type int count empty square neighbors, and it will take an integer x and an integer y, and for now we will just return -1. So we will say, after our walk, we say if count empty square neighbors of our start position dot value, let's copy that, dot x comma dot y is less than 1. If we don't have neighbors. So this is, we found a cell by itself with no neighbors. Time to panic. Okay, so let's say now in here we want to gather the list of indexes around this location. So let's say list int of indexes equals a new list int. Then we say if the start position dot value dot x is greater than 0, and the indexes does not contain the grid at start position dot value dot x minus 1 comma dot y. And let's just copy this. And then let's say the indexes dot add the grid at start position value x minus 1 y. Okay, so it's a bit hard to see. Let me zoom out, because now we want to copy and paste this once for each direction. Okay, so the next is if the x is less than the static game controller dot width minus 1, and the indexes does not contain the x plus 1, then we add x plus 1. Then over here we need to say y and this will be y minus 1, y plus 1. And again over here, let's remove the x minus 1, and let's do y minus 1, y plus 1. Okay, so if the y is greater than 0, or the y is less than the static game controller dot height minus 1. Okay. So make sure that you have these copied exactly, otherwise you will most likely have an error. Okay, now we want a for each. Let me zoom in again for you. So we want to say for each int end in indexes, and then we want to say for each vector to int in walks at end -1, then we want to say that the grid at vector to int dot x, vector to int dot y is equal to 0. Then we want to say list of vector to int, and we'll call this one walk 0, is equal to a new list of vector to ints. Then I will say vector to int question mark second position is equal to get random start position. Oh, we don't have this function yet. Okay, so let's do this. Let's have a vector to int question mark called get random start position, and it will return null for now. So the second position is equal to get random start position. Then we say if second position dot has value, then, and we will also have this as another function. So underneath our while statement, but before we leave our generate location, so right here, let's create a recursive walk function. So I'll say void recursive walk, and we want our recursive walk to take, let's see, there we go, that's what it is. So it's not a void, it's going to be a list of vector to integers called recursive walk. It will take a list of vector to integers called walk. It will have a vector to int called the start position. It will have a number of steps, and it will have an integer index. And for now, it will return null. Okay, so if the second position has value, then we want to say recursive walk with our walk 0, our second position dot value, and then we want to say walk times %2 equals 0. So is it even? Then we need to subtract 1. So we will say walk times -1. Otherwise, if it is odd, then we just return the walk times. I find that we get a lot more errors if we return an odd number of walk times with an odd number of grid sizes and an even number of walk times with an even grid size. Not quite sure why, but it does. Something about math, I suppose. Perhaps it's just the random generation that I saw. And then finally we say walks at index minus 1 is equal to walk 0. Okay, so what we are doing is we are just recreating our walks and hoping that they fill up this area. And then finally we want to say that our walk index is subtracted by 1. Okay, otherwise, else, what else do we do? Our cell has neighbors. Have it walk. Okay, so now we want to say recursive walk, which will take the walk, it will take the start position dot value, and let's actually just steal this, but instead of indexes, it's going to take the walk index plus 1. We actually need it to be walk index plus plus. Yeah, that's rather sloppy of me. Okay. Yeah, just had to double check something, so it's going to be walk index plus plus for our recursive walk. Now we want to say another vector2 int with a question mark, so a nullable. Let's say rand start position, and this is going to be equal to a get random start position. Then we want to say if, let me check something. Okay, so then we say if the rand start position dot has value and the count empty square neighbors of the rand start position dot value dot x and the rand start position dot value dot y is less than 1, pretty much we found a cell by itself, has no neighbors, we need to panic. But we're just going with a nuclear option where we say if the static game controller has the random seed, then increase the random seed by 1, clear the walks, and then generate the locations again. So we are just resetting. So this can also be called reset. And then we'll say else where everything is all hunky-dory. Then we'll say walks dot add walk. And then finally at the end, let's see, after our else, but still within our while, because we need to give a new start position, so we will say start position equals get random start position. Okay, now if we minimize our while, we'll just see our recursive walk. I do actually want to drag my random start position in here. And I believe the count empty square neighbors needs to be in here as well, or should be. Okay, so now let's look and see what we do in our recursive walk. So the first thing I do in the recursive walk is I say that the walk will add a new vector to int of the start position dot x comma start position dot y, then the grid at start position dot x comma start position dot y will be equal to the byte what is it called? Golly, when you or cast, yes, the byte casting of our index. Okay, then let's say vector to int question mark next direction is going to be equal to, and let's go down here and let's say vector to int question mark next direction, which will take an integer x and an integer y. We are not going to add code to it yet. We will just return null so it stops giving us an error. So we will say next direction equals the next direction at start position dot x comma start position dot y. Then we say if the next direction doesn't equal null and the next direction dot value, okay, so we do want it as a vector 3. So let's change next direction to a vector 3 int, vector 3 int. So next direction dot value dot z is equal to -1 or the steps are greater than 0. So if it's not null and our next direction z value is -1 or we have more steps, then we want to return a recursive walk, which will take our walk and a new vector to int of our next direction dot x comma next direction dot value dot x dot value dot y, and then it will have minus minus steps and our index. Okay, otherwise just return walk. So this is our recursive walk. It adds the new starting position it sets it in the grid, and then it tries to get the next direction. Does it go up, down, left, or right? If the next direction is null, if there are no next directions, then it will stop. However, if there are still directions, and the next direction, we must take the next direction. It's a space with no neighbors, pretty much, which would cause a broken game. Or if we still want to walk. Then we will continue walking. Okay, so that's our recursive walk. We can even add a quick comment of crawls randomly across our grid. Okay. Now for our next direction. Let's look at this. So the next direction, we want a list of the vector 3 integers, which will be the possible positions. And this will equal a new list of vector 3 int. Then we want to say, is this, actually let's add the comment later. So let's say, if x is greater than 0 and grid at x minus 1 comma y is equal to 0. So what we are doing is look for empty neighbors. So x is away from the farthest left edge, and the grid at the space to the left is unoccupied. Then we want to count the empty square neighbors, and we say if count empty square neighbors, and we'll pass in the x minus 1 and the y, and we say if it is equal to 0, that means there are no neighbors to the left, I believe. Then we want to stop looking and return it right away. So we will say return a new vector 3 int of x minus 1 comma y, and then a negative 1, which means we must move there. Otherwise, we say the possible positions dot add, and it will be a new vector 3 int of x minus 1, y, and 0, which means we do not have to move here, but we can if we're still walking. Okay. So let's copy the insides of this, and we will say else, oh no, not else if, we'll say if x is less than the static game controller dot width. So is it less than the farthest right corner, minus 1? And the grid at x plus 1 comma y is equal to 0. Then if the count square neighbors at x plus 1, then we have to return x plus 1 negative 1, else add it as 0. And let's copy both of these now, because we are going to be replacing the x's with y's. So if the y is greater than 0, and the grid at y minus 1. And then let's remove this minus 1 and add it to the y. Remove the minus 1, make sure you add it to the y. Okay, now we need to change this, so if the y is less than the height minus 1, let's remove this plus 1, and there we go. Okay, y plus 1, y plus 1, and then one more right here. Okay. Then we go down and we say if the possible positions dot count is equal to 0, then return null. Otherwise, we will return the possible positions at a random dot next of 0 to possible positions dot count. So otherwise we just return a random position. Okay, so gets the next random direction. Okay, now for our get our start position. So let's empty this out, and let's say int min neighbor count, and let's set this equal to 5 for now. Let's also have another list of vector2 integers, which we will call the start positions, and we will set this equal to a new list of vector2 integers. Okay, now we need a double for loop to loop through our grid. So let's say for int I equals 0, I is less than the static game controller dot width I plus plus. For int j equals 0, j is less than the static game controller dot height, and then j plus plus. If the grid at I and j is greater than 0, then simply continue. So pretty much is the space that we are looking at occupied. Okay, if the grid is not occupied, then we want to say that our int NEIGHBORCOUNT, if the integer of the neighbor count is equal, or we set it equal to count empty square neighbors of I comma j. So we count the number of neighbors that they have. Then if the neighbor count is less than the minimum neighbor count, and we'll look at the count empty square neighbors later to see exactly what it is. And we will say if it is less than the minimum neighbor count, then start positions dot clear. Okay, that's why we're doing it. Then the minimum neighbor count will equal the neighbor count. The start positions will add a new vector to int of I, comma, j. So what this says is our minimum neighbor count is 5. The maximum count that you can ever actually get is 4, which means the first neighbor that we find will, call this function. But now say it is now a neighbor of 2, then it will say, okay, well, we only have 2 neighbors here. And it will clear out all of the neighbors of the space before. But then say we're going through, we add a few more neighbors of 2, but then we find a neighbor with only, or a cell with only 1 neighbor. That would destroy all of the neighbors of 2 and then create a new list of just cells with 1 neighbor. Okay, so the neighbor count equals neighbor count, and then we say else if the neighbor count is equal to our current minimum neighbor count, then we need to add this to the list. So we will just say start positions dot add. Okay, let's go outside of our for loops down here, and we will have our return function now. We will say return start positions dot count is equal to 0, question mark. If it is equal to 0, then return null. Otherwise, return the start positions at a random dot next of 0 to start positions dot count. Okay, and now we have chosen a random start position. Choose a random start position from the empty cells. Okay, we need to count our empty square neighbors. So for count empty square neighbors, we will say that the integer count is equal to 0, and we want to return count. In the middle, we will say if x is less than 0 and the grid, I'm terribly sorry, if x is greater than 0 and if the grid at x minus 1 comma y is equal to 0, then we say, oh, that's supposed to be a comma, not a period. Then we say count plus plus. Okay, now we say the bottom 2 are going to be y, and if you've been paying attention, it would be y is less than the static game controller dot height. This would be x is less than the static game controller dot width minus 1. Make sure you add those minus 1s in there. Okay, this would be y minus 1, this would be x plus 1, and this would be y plus 1. Okay, so we have x greater than 0 and the grid at x minus 1 and y is equal to 0, count plus plus. If the x is less than the static width minus 1 and the grid at x plus 1, y is equal to 0. If y is greater than 0 and the grid at x at y minus 1 is equal to 0, then the count increases. Y is less than the height minus 1 and the grid at x at y plus 1 is equal to 0, then the count increases. So it counts all of the neighbors of 0 around it, while protecting you from having an index out of bounds error when you get to the edges of the grid. So this says counts the unassigned neighbors. Okay. Whew. And we are done with the generate locations. Generates locations. Okay, so we are now working on the place images function, and what we have is we have our locations in our grid now, but we do not yet have any images being displayed on screen. So what we want is pretty much this right here. So like I said, we would be taking this later. So let's highlight our new images multidimensional transform array, and I'll just drag it over and put it into place. I'll add a tab so it's spaced properly. And then I want to get some cell sizes. So the images that I am using, I find that they have a cell size of 2.4F. With the images that you use, they will be different, and you will need, different math for all of them, but I did make my cells myself, and it is pretty basic stuff, so I think I will provide the resources in my GitHub for you to use for free in your game. I suppose the only thing that I would ask is perhaps a mention, especially if you're, using it commercially. Okay, so the next thing we want to do is, I find that we actually need to go through the height and then the width first, as funny as that sounds. So let's do for int j equals 0, j is less than the static game controller dot height minus 1, no, just height, and then j plus plus. Okay, now we want an inner loop, so let's do for int I equals 0, I is less than the static game controller dot width, and then we do I plus plus. Okay, and then we want to say that the int index equals I and then minus the static game controller dot width divided by 2. So to give you an example of what this is we want to have our images put in the very center. If we do not have the width divided by 2, here I can show you in Photoshop what exactly we are doing. So let me open a new Photoshop. Okay, so what we are doing, we have a grid that is Y and X. If we start placing our stuff at 0, then the first one will go here, the second one will go here, and so on, like this. And then we end up having a grid like this. But we don't want the odd offset on our grid, so what we do is we say take the width of 5 and then divide it by 2 and then subtract it from our current index. So our new grid will be like this. So this cell right here is index 0, 0. This index right here would be 3, 0, and this one right here would be 3, 3. However, the actual index, as you can see from the point here, would be 1, 2, 1, 2. So this is actually 2, negative 2 in our grid. And this one is actually negative 1, negative 2, 1, 2. So this one is actually negative 2, 2. So what we are doing is we are just pretty much moving it over halfway to the left and moving it down halfway, because otherwise it would be in this area right here, and we don't want that. Okay, so that's a quick description of what we are doing, just some visual aids to get you with. And now we want to see if it is on the left. So is it to the left of 0? Or not left of 0, we want to say yeah, pretty much. I suppose we could just say is index less than 0, but I don't. What I say is if I is less than the static game controller dot width divided by 2, and then else. So if I is, then I will say index plus plus, and I will call a function that we will add below here. So let me create a function void get y, which will take a float x, and we will add code to it later. So what I will say is I will say index plus plus, and then I will say get y with, and then I will say some complicated math stuff. So I'll say get y at the cell size times the index minus half of the cell size. So again, with the cell itself, the cell self, let me add a background to this. No, let's just do a color. No. There's a way to add a solid color. Oh, well, I'll just use the paint bucket. Okay, so what is happening now is with our cell, we have, again, our grid. If we place our cell, it would be placed here. But we don't want that. We want our cell to be in the center. Let me grab another color. Yeah, let me actually do that twice. So where our current cell is it's right here. But we don't want our cell right there. We want our cell to be right here. That means we must move our cell over half this way and half this way. So we need to say half cell size on the x and then half cell size on the y to translate it to the center. Now you can try this without this function and see what happens. I definitely recommend, don't just copy and paste my math, but struggle through it, because I did spend a good day or so doing all of the different math, finding out what mathematical functions did I have to do and what values did they come up with. Okay, anyways, we say the half size, the cell size times the index minus half of the cell size minus the width of our grid %2. So is it even or odd? If it is even, then we add 0. And else we add, or else we subtract half cell size. Now again, to illustrate what exactly this is, you know what, let me just paint it there and I'll create a new layer. Okay, so what is happening here with our is it even or odd, subtract the half cell size, we have our grid. Now, if we have a grid of 4, this is a 4 by 4 grid. We want it to be here. So 1, 2, 3, 4. There we go. So it's a 1, 2, 3, 4, 1, 2, 3, 4, a 4 by 4 grid. So to move it over, it just needs to be half of the grid size. However, if we have a 3 by 3 grid and we only move it half, what we would see is we would see this. This would be what happens if we use a 3 by 3 grid with the 4 by 4 grid method. So what we need to do is we need to add an extra half chunk. So 3 by 3, let's say, adjusted. Now, with the 3 by 3 adjusted, I'm going to have this grid, but I'm going to move it over half of a cell size. And that way, it is now going to be about here. So the center of the grid is in the center of the 5th square, or the center of the center square. So the center of our grid is the very center of this. And that's why we need to adjust it and move it over by half if it is odd. And pretty much what %2 is %2 is a modulo, which says if it's 1, return 1. If it's 2, return 0. If it's 3, 1. So it keeps everything in the range of 0 to 1. If we say modulo of 3, it will keep everything in 0, 1, or 2. Modulo of 7 is 0, 1, 2, 3, 4, 5, 6. Like that. Where something like 14 modulo 7 is 0. Okay, but that's just some kind of advanced math stuff, I suppose. Okay, and then our other one with our else, we will not increase the index. So, what this is saying is, okay, well, let's draw this out too, because this is also very interesting. So what the index plus plus says. So say we have our range. So for a 4 by 4 grid, we have the numbers 0, 1, 2, 3. But when we translate this, what we say is I minus 4 divided by 2. So we would say what this is now negative 2, negative 1, 0, 1. But we cannot multiply by 0, otherwise we would have a pretty messed up grid. We would have a grid where we have, you know, the left side looking perfect, but then the 0 is going to be in the middle right here, and the 1 is going to be half a size over. And it would be very messed up like you see here. So what we need to say is we say if greater than width, then we plus 1. Then it's the index plus 1, which now for the 0, 1, 2, 3 gives us negative 2, negative 1, 0 plus 1, and 1 plus 1, or 1 and 2. So now we have the flipped opposites, which is exactly what we want. Okay, So now, without further ado, that's a good description of what exactly this does. Hopefully you understand. If not, definitely ask questions. But now, with this, we want to say the transform, and we'll just call this transform. No, let's say self-transform, because we don't want to override the this transform, and we'll say that this equals instantiate. Instantiate our cell prefab in the instantiation location that we will set later, dot transform. So this will create the cell prefab create a new object of the cell prefab type in our instantiation location, and it will grab its transform so we can move it around, because we will not actually be affecting the game object. Then we want to go to our new images grid here that we have not set yet, and we will say new images at I, j is equal to transform. Because we will be using this later in our walk index, I believe. Yes, we will be using it later. Okay, so we have the transform. Then we want to say that the int index, so we will have a new index, and we will say that it equals the negative j minus the static game controller dot height divided by 2. Now you might wonder, why are we, we recognize this. This is very similar to what we did here. We're just using height and j, or height and j instead of width and I. But why do we have it multiplied by a negative? Now that is also a very good question if you were wondering, and a very simple explanation. So what Unity would do is it would say build this, build this, build this for a 3x3 grid. And then it would say build this, build this, build this, then this, then this, then this, where our grid goes from the bottom to the top and the left to the right. But we don't want bottom to top, so what we do is we say multiply this by -1. So multiply y by -1. So our new grid will go 1, 2, 3, 1, 2, 3, and it's more human, as we expect, from top to bottom instead of bottom to top. And that's what the -1 does. So pretty much this is 0, 1, 2, but what we want is 0, -1, -2. So that's why we are adding the multiplied by -1 right here, or simply flipping the value of it. Okay, then let's also give it a name. So I will say transform.name equals, and I will say cell object, and then I will say plus I plus underscore plus j. Cell object space. Okay, there we go. So this will now give it the name of something like cell obj space 1, 2. And then let's get the cell from it. So let's say cell C equals transform.getComponent, and let's get the cell component from this. Okay, then we want to say into our game controller, which we have not added this yet. So in our game controller, let's have a list of cell called cells. Oh my. Let's try this again. list control period adding generic. List of cells named cells equals a new list of cells. And we'll make this internal. Okay, so make sure that this is in your game controller. You have your generic collections, and we go back to our grid generator, back to where we were after we just got the cell component. And I will say that the game controller dot instance dot cells dot add, and then I want to add C. Now the order of the cells here does not matter, because the only thing that we are doing this for is to keep all of our cells so we can see if they are filled when we want to see if the game is over. So we say add it to the cells. Then we want to say c.initialize. So we are now initializing it, and we want to initialize it with ij as the x and y. Now we want to say if j is less than the static game controller dot height divided by 2. Pretty much the same thing as over here. We're seeing, is it below 0 or not? Do we need to increase the index? Just to keep it, off of 0. Okay. So yeah, we say divided by 2. And then we say, in this case, because with this one we are doing the positive, but this one we flip the sign, so we also need to flip the sign here. So instead of index plus plus, we are now saying index minus minus. Okay. You know what? And in fact, we only use index once, so let's do plus plus index and save ourselves a line. And then we'll also do minus minus index over here. So we will say that the transform.position is equal to a new vector 3 of x, comma, and let's get the cell size times the index, and let's add minus minus index, plus half cell size, plus, and then we are doing the same thing as over here, but instead of width we are checking height. But we can still copy this exact thing and just change width to height. Now you can also see that over here we want to add the sizes. And this will change as well. Now I did make a mistake. In our static game controller width, the second one, the else one, we do want to add the half cell size. So I am sorry about that. Let's make sure that you fix that, otherwise you will see your grid a bit messed up. So we have minus plus. So this one will be plus, and yes, and then it would be minus. So then I say else, and I paste it in there, and plus, and then this one is now minus. We need to remove this minus minus, but everything else is hunky-dory. Okay. Now let's go outside of our for loops. So if we minimize our for loops, we want to go below them, and we want to start going through our walks and setting our cells. So int walk, or setting our heads, walk index equals 1. Then I say for each list of vector 2 int walk in walks. I will pick a color, so I will say int index equals random dot next of 0 comma available colors dot count. Then I will say color equals available colors at index. Then I want to say available colors dot remove at index. So what we do is we grab the index of a random color, we take that color, and then we remove it from our list. The next thing we want to say is we want to say fill the colors again if we run out. So pretty much if you do not have this and you don't have enough colors, you can throw an error of index out of bounds because you are out of colors. And you don't want that. So what we will say is we will say if available colors dot count is less than 1, then available colors dot add range of our colors. So it adds all of our colors back to the available colors like we did in the start function. Okay, and that's just a quick little thing. Then we want to create a new line. We'll say line equals a new line. And we can do this because it does not inherit from mono behavior, or it doesn't expand upon mono behavior. Okay, so the line equals new line, and then we say line dot initialize, and we will take the walk at 0, which is the first part of the walk. Where did we start the walk? And then we will take the last part of the walk. Where did we end? So we will not tell the player what is in the middle, but we will fill up, or we will show them both sides of it. So then we have the walk at, oh, I'm terribly sorry. So let's go here. Let me comment this out because we want a quick function called cell get cell, which will take a vector to int named position, and all we want to do is we want to return a new images at pos.x comma pos.y dot get component. You know what? If we're getting the cell anyways, let's do this. So I'm terribly sorry again. In our get y, in our for loops, in our get y, instead of having a transform of new images, let's actually just do a cell. A multidimensional cell array of new cells. Then we will say that the cell C, or the cell equals, and then here we will remove transform, and we will get the component of the cell. And then we will say cells, right? No, new cells. New cells at I equals cell. So what we are doing is make sure that you make these changes in our place images, in our double for loop, in our get y, we are now grabbing cells, and we say get component cell. Yeah, I should have caught that ahead of time. We want to say cell.initialize cell.here, and we'll just delete that getter. Then when we, so now once you have changed all of that, let's also say make sure that you change all of the transforms. So this is cell.gameObject.name. This is cell.transform.position. Because if you do transform.position, it will change whatever script you have this, or whatever object you have this script attached to. And we don't want that. So make sure you have the cell.transform position and the cell.gameObject.name. Okay, now over here we can say the new cells. And we don't even need this anymore, so let's just grab new cells. Okay, go back here, line.initialize our new cells, and this is going to be at walk 0 dot x comma walk 0 dot y. Then we are going to say, let's add a square bracket there, comma, now this will not be walk 0, this is going to be walk at walk dot count minus 1. So let's cut that out. Let's add new cells at dot x comma dot y. So quite a lot to unpack there. Then let's add the color that we found, and let's cast to a byte our walk index plus plus. Okay, so let's go through this. Here, I can even space this out for you so it's a bit easier to read. Oh, terribly sorry there. That's not what we want. Okay, there we go. So we have the initialize, which initializes the value in this line of head A, head B, color, byte. So head A is the first addition, head B is the last addition, the color, and then the byte. Okay. Then we want to go to our game controller and we want to add the line. Now we do need our line, so let's move over back to our game controller and let's just copy this list of cells and we'll say a list of line. Let's copy that. Let's say L-I-N-E-S. Oh no, not lions, lines. And then paste it here and save it. Okay, so you should have this internal list, line, lines, new list, line, line, or new list line. I'm terribly sorry there. And then we want to say the game controller dot instance dot lines dot add line. Okay. Then we want to say nothing. Okay. So that's the end of our place images. So we will say creates and places images on the screen. Okay. And finally, I want to do something to print the grid. So for debugging only, shows the base values after walking. So what we want to say is we want to say string s equals an empty string, and then for and I equals 0, I is less than the static game controller dot height I plus then let's say if I is greater than 0, we will say s plus equals a new string of our dash character. Make sure you use the single thing, so it's the dash character, and I will say the static game controller dot height times 2 plus the new line character. Then I will say for the int j equals 0, j is less than the static game controller dot width, j plus, and then we say pretty much the same thing here. So let's do if j is greater than 0 and j is less than the static game controller dot width, minus 1. No, we can just remove that. So if j is greater than 0, then we want to say s plus equals this bar. Oh, shoot. There we go, this bar. Okay, and then we also want to say s plus equals the grid at j comma I. And at the end of our for loop here, we want to say s plus equals a new line character. Finally, at the end of our for loops, we want to print s. Okay, so that is our grid generator. I do believe we need our game controller and our input handler. But we've done quite a bit onto our game controller. Let's see. But I will still leave it for last. So let's go to our input handler. Now our input handler will capture, so a typical input handler captures the input from the player and allows them to control the game. Okay. So the first thing we need is we need our main camera. So let's say serialize field, and let's say camera, and I will say main camera. And then I want a serialize field with a transform mouse position tracking cube, because that's pretty much what it is, well, exactly what it is. And let's say serialize field, and we'll say the box collider of the mouse cube box collider. And you'll see why we have these later. Let's get an internal bool for is clicking. You know what, let's just make that a bool. Let's see if that's just what we need, and let's say it is equal to false by default. Let's also have a Boolean value for has released, which will equal true. And then awake, we say the instance equals this. And let's go to our cancel click. So that will say game controller dot instance dot check game, which is a function we don't have yet. So let's copy that name. Let's go over to our game controller, and for this let's just say internal void check game, save it, go over here, the error has gone away, and after that we want to say is clicking equals false, and the mouse cube box collider dot enabled is equal to false as well. Okay, now above the cancel click, so let's say the description of this is cancels the player's click so the mouse position no longer affects the grid. Okay, and let's go into our update. So our update, we actually have quite a lot going on. First, let's actually go back to our game controller. Again, we've got lots of small things that we want to add here, and we want to say we need an internal static bool of is game active, which will equal false by default. I'll make it true by default. Okay, now let's go back here, and in our update I will say if game controller dot is game active. Perhaps I will not make it later, but oh well. And then I will say the vector 3, which I will name v3, is going to be equal to our main camera dot screen to world point of our input dot mouse position. So I will take the camera and see where the mouse is on the screen, and I will convert it to a point in the world. Okay, then I want to say the mouse position tracking cube dot position will be equal to a new vector 3 of, now we have quite a bit going on here with quite a lot of math, but we've already dealt with most of this. So we will say the new vector 3 is equal to the v3 dot x times the grid generator dot horizontal move multiplier, comma, okay, looks like we can safely remove that, comma, and let's do the, now this one is so let's have a serialized field float, and let's say height offset equals, now I'll have my height offset equal a negative 1.59f. Now this is what you will have if you copy me exactly. You will need to set this to a value that works for you if you do not follow me exactly. Okay, so we'll say the, you know what, we can even do this. So we say the width offset equals 1. So then we have v3.x, sorry, let's make it 0. v3.x plus the width offset v3.y plus the height offset. So this will subtract 1.59, moving my mouse position up, or moving this cube up. Okay, then I want to multiply that by my grid generator dot vertical move mouse move multiplier, and then finally we want 0. Okay. So that's, say, hashtag region, control, or move our mouse tracking cube. Then hashtag end region or pound, if you will, and then I'll press enter. Now we want to say get clicks. So we say if input dot get axis raw. We don't want get axis, we want get axis raw. And this will get the fire 1 axis, and we say is it greater than 0. Pretty much the get axis raw is like the get axis, but get axis raw returns either 0 or 1, and I find it much better to use than get axis, because get axis will return a gradient value. It will go 0, 0 0.001, 0 0.002, like that, all the way until it gets all the way up to 1, while get axis raw is either 0 or 1. And it's a sharp transition. So if you want, the smoothing off, you want the axis, but we just want is it or not. Okay, and it can take a while for it to go away as well. So we say if not is clicking and has released. Then we say is clicking equals true. The mouse cube box collider dot enabled equals true, and our has released equals false. Then we need to say else we want to cancel our click, and has released equals true. Okay, so what this does is it will check when we click down on the mouse, and it will not check again until we have let go. Even if we cancel the click, we need this has released, otherwise it would just set again instantly. Okay, and that is all we need for our input handler. So I look forward to showing you that in action. And the final thing, the thing that we kept jumping back to, our game controller. So let's look at our game controller, where we have quite a few things to add. Okay, so we have our instance, we have our list of lines, we have our list of cells, but let's go through and let's have a few things. So let's have a cell for the current cell. We want a line for the current line. We want a cell of our last cell. We want a tracker. Let's have an int of moves count, which we will set equal to 0. And let's just get a few things. So let's get a serialized field of a game object, which we'll call the game over screen. Let's get a serialized field of our tmp underscore txt control period using tmp pro. It should be added at the top, and this text will be called our moves text. Let's copy it 2 times so we have our filled text, not filed text, and then we have our level title text. Okay, and is game active is true. Now we do want a start. So in the start, we want to say that the level title text.text is equal to the static game controller.width plus the letter x plus static game controller.height. And this would give us a 5x5 or 5 by 5 on our title. Okay, so let's go to change current cell right here. Let me move this down, and I am going to be right back. Okay, so in our change current cell, let's look at that. So this will be ran, let's do a triple slash. Ran when the player moves their mouse from one cell to another, or when the player moves their mouse into a cell area while clicking. And the cell is the cell that we just entered. Okay, so first we want to say, are we currently clicking anything? So are we currently clicking anything? Question mark. We want to say if the current cell equals null, which means we are not clicking anything, is the cell we are clicking a head. So if cell dot is head, then we want to say that the current cell equals the cell. We want to say cell dot line dot clear, so empty the line, and then cell dot line dot add cell. Then we also want to say moves count plus plus, add 1 to the moves, and we want to display our moves. Now we don't have a function for this yet, but let's just add that real fast because it's very simple. So let's have void display moves, which will pretty much say that the moves text dot text is going to be equal to moves colon space plus moves count. And that's really all moves display moves is. So let's copy that and let's paste it here. So anytime we update our moves, we also want to display it. Okay. Otherwise, so then we say else, and then if cell dot is selected, so we already have a line here. If the cell is selected, then we say the current cell equals cell. And actually, for our moves count right here, let me just say if the last cell doesn't equal null and the last cell dot type index equals the cell dot type index. and the type index does not equal. There we go. Okay, so let's drag that here. So we only increment the moves if the last cell that we were clicking is not of this type. Let's say and last cell dot is head. So if the last cell is a head and it okay. So let's see. We want to say first. No. The last cell is equal to null. Or, so if last cell is null, then we add to the moves. Or we say, is the last cell type index equal to the cell index, and the last cell dot is head, and so these things, but reversed. Or not, oh, the not needs to go on the outside. Okay, so if the last cell is null, true, add to the count. If the last cell is not null, then if the last cell is head and it is this type, then don't do it. So true, false, or, and then this would be true, meaning this is false, which means it does not run this. Okay, so that's pretty much what we want to do. Hopefully you understood that. If not, definitely look into some discrete mathematics and some Boolean calculations. Okay. Then we also want to say that the last cell equals cell. You know what? Yeah. So let's do this. Okay. Then, if the cell is selected, we say the current cell is equal to cell. We say if cell dot post doesn't equal null, then the cell dot post dot unset. So what this is kind of saying is it's saying, well, let's go to my handy dandy Photoshop Mandy. And what we have here is a failure to, so we have a grid. Say it's a 3x3 grid, and I have my red cells. I have 1, 2, and then I drag it up to 3, and then I go 4, and then 5, and I stop. And then, if I were to click here, what it would do is it would say backspace, backspace, all the way back to this one. So it clears the post and clears the post to remove those and take me back to the cell which I just clicked, which is this one right here. So that's all that does, and that's why we have that clear function as well, or the unset function. Okay. Then we also want to say if, so we're pretty much doing another form of this. We say if the last cell doesn't equal null, and the not last cell dot equals cell. So if the last cell is not null and if the last cell, no, we want to say if the last cell is null or, oh my, if the last cell is null or the last cell does not equal our cell. Let's actually do last cell dot is connected. So if the last cell is not connected to cell, then we want to do the moves count in display cell, followed by our last cell is equal to cell. Okay, and then finally we say else. We want to say input handler dot instance dot cancel click. Okay, and that's the first part. If our current cell is equal to null. Now we have another one. Let's say else. Yes, we are dragging our mouse. Okay. Else, we want to say ensure that the cell is a direct neighbor. So we say if the current cell dot x is equal to the cell dot x, oh my, cell dot x, and our current cell dot y plus 1 is equal to our cell dot y, or our current cell at y minus 1. So is it to the top or bottom? Now let's go and let's copy this and let's say or this. And just to give you a better view of it, let's bring it down here. And we want to change x to y. We want to change y to x. So if the y is the same, which means it's like right here, then if x plus 1 is equal to x, or x minus 1 is equal to x, same thing here, y plus 1 or y minus 1. Then, and then we say else, and we'll just cancel the click otherwise. So we say input handler dot instance dot cancel click. Okay, you know what, let me look at the input handler. Can I make the cancel click static? No, because we're using the is clicking. Okay. So yeah, then we just cancel the click. But if we are not canceling the click, then we want to say ensure that the cell is not the head of another color. So if not current cell dot equals cell, so make sure that the current cell is not this cell, and not cell dot is head, and cell dot type index doesn't equal the current cell dot type index. So if it is a head and the indexes are not equal, then we cannot connect to it. But if it is a head and the type indexes are equal, then it can. Or if it is not a head, then it can. Okay, so what we want to say is we want to say current cell dot line dot add the cell. And we'll say the current cell equals cell. Let me look at one thing real fast. Okay, and when we use this, that's another change currency. Okay, so let's just go through here, and in our current cell equals null, cell is head, I want to remove this last cell, which means just anytime we click a head, no, I'll keep it. I like it. Okay. Okay, current cell equals cell, yes, okay. And we want a new function to display the filled count. So let's do void of display filled count, which in order to get this we also need an int for count filled cells. Now in count filled cells we say int count equals 0. Then for each cell in cells, if the cell dot is selected, then we say the count plus plus, and finally we return the count. Okay, now in the display filled count we say that the filled text dot text is equal to connected colon space plus count filled cells plus the slash plus our cells dot count. Okay, and then at the end of this we want to say display filled cells. No. Yeah, display filled count. Okay. So this will slash count the number of cells that are selected. displays the number of connected cells versus overall cells on the screen. Displays the number of moves made on the screen. Okay. There we go. Whew. Now we want our check game. So for our check game, we will say that the current cell is equal to null. We will say that our last cell is equal to null. We will say for each line in lines, if not line dot is connected, return. Then if count filled cells is less than cells dot count, return. Because we can't have every cell filled while not being connected, and we can have, oh no, I'm out, and we can have all of our lines connected without every cell being filled, so we need to check against both. So sad. And then, if we still have not returned, then we are done. We say game active equals false, and we will say the game over screen dot set active is true. Okay. And I'm not going to get into the other details. You know what, let's do one last thing. So let's say check if the game is finished, and as one last gift to you, we will say public void new game, which will say is game active equals true, and then scene manager. Okay, let's type it out. SCENEMANAGER control period yes using Unity Engine Scene Manager. Scene manager dot load scene, and it will load scene of the scene manager dot get active scene dot name. So this just reloads the active scene. Okay, we can delete our current line. We aren't using that. Okay, so if you've been following along with me and you've played your game, then you would notice that there can be pretty large errors. Now, I wrote down two of my codes that ended up displaying a broken game, and that is because I did not copy my previous code properly. So let's look at our grid generator at our generate locations. We will keep our initialize the same, so the grid equals a new byte of width and height, and then for each of those we set it to 0, and we do want our walk times to equal whatever is higher, the width or the height, and we do want our walk index. But I want to take my start position and I want to drag it under the walk. I want to delete my temp and I want to change my while to be get random start position dot has value. Okay, and then for the start position, I will also have it be I will also have it check for the walk index equal to 0 question mark. If it does equal 0, then otherwise it will do the get random start position. Okay, so that is our new start. Then, after we have the start position, we want to say if the count empty square neighbors start position value x and value y is less than 1, then, and let's just go through this again. I don't believe the change we need to make is here, but we will say the indexes list int, and then we have greater than 0, less than width minus 1, greater than 0, less than height minus 1, and with minus 1, minus 1, plus 1, plus 1, minus 1, minus 1, plus 1, plus 1. Okay. Then in the for each index and indexes, and then for each vector2 int in the walks at index minus 1, we will be setting the grid at x, y to 0. Then we say that the walk at 0 is a new vector2 int, the second position is a random start position, and if it has value, then walk through with our walk, our value, and then -1 or normal with the index, and then the walk at the index minus 1 is equal to our walk 0 with walk minus minus. So nothing actually changes there. And let's look in our else. So our else will be the recursive walk start position value %2 minus 1 times, and then walk index. And we don't want the walk index plus here, we just want walk index plus 1, because we want the plus in a different location. So we want the plus 1, and then vector, because plus actually assigns to the value, just like minus minus. Okay, then vector 2 int random start position is get the random start position, and if the random start position has value, and we can count the squares at x and y and it's less than 1, then we are just going to abandon the game. So we say the seed is plus. I will not actually print error, but I will say clear the walks, generate the locations in return, and finally add the walk. Down here I'm going to delete all of this extra stuff, and this is at the end of our while statement. So we can see that it's at the very end, you see the highlight there, and this is where I will say walk index plus. So this is where I will increment the walk index. Okay, and I believe that should be the only thing that we need to change. I did come across a few other changes that I noticed. So in my line initialize, when we set the head A and head B, we do need to pass true as well to tell our game that it is a head. And then in our cell, when we initialize, we should also set images. As for our input handler, I don't believe that there were any other changes to make. Let's see, in our static game controller, no other changes to make. And then game controller would be the other thing, and no. So what if at the end of our place images we say game controller dot is game active equals true. There are bound to be a few things that we have extra here, but let's see. We have cell filled out, game controller filled out, grid generator filled out, input handler filled out, line filled out, and our static game controller all filled out. Perfect. So then let's go into our scene. Let's wait a while for everything to reload, all of our script assemblies to reset, and we are going to start to go through the process of setting up our canvas. Now, as I said before, the math that I performed was for my exact setup. If you change the setup, you will need to redo the math. As you will see, there will be the things like the mouse following script will be off, the grids will not generate as you expect them to, and everything like that. But first, let's actually create a new scene. So C#, create scene, and I will call this the setup scene. And then let's also in our script, let's do this. So create a C# script, and let's call it the scene loader script. And in the scene loader script, we want a very simple script. Let me go here because I have the script here where we want it to be the, yes, this one. So let's just destroy all of this, and I will call it the public void of open scene with the string scene name. And this will say SCENEMANAGER control period using Unity Engine Scene Manager dot. Oh no. Load scene of scene name. Okay, so one last script for us to add. Let's go back to our playground and let's set up our scenes. Now we do not want to add our Pathfinder scene. What we do want is we want our setup scene. So let's save it, go to our setup scene. In our setup scene, I want to change this to the 70-70-70 that I use on the other scene. I will also set it as a solid color just for myself. And let's see what we want to set up. So I do want a canvas with some buttons. So let me do a right click UI image. Now it's added a canvas, an image, and an event system. Let's look at the canvas. I want to scale it with screen size. I'm using a 16:9. So let's multiply that by 200. So it would be 1,800 by 3,200. And I want it to expand. Okay. Now this image I want to have be the back button. So I'm going to place it at the top left, but I'm going to move it over 100 and negative 100. You know what, let's actually do everything exact. So 50 and negative 50. Okay, I think I will also make the width 300 because I will add a UI TMP Text Mesh Pro onto it, which will say BACK, and it will be of the, let's do a dark black color. Let's make it emboldened. Let me stretch the anchor presets with Alt and Shift, and then click the two arrows. Let me set it in the center. Let me auto size it, give it a maximum of, oh sorry, not 30 but 300. Okay, it's at about 90. So let's go with 90. Okay, and that's just a quick ugly back button. Now I do want another thing. I want a right click and create empty. I'll call this the vert layout. For the vertical layout, it's going to fill up the whole screen, but I will add some padding. There will be 100 padding from the left, there will be 450 from the top, and 100 from the right, and 100 from the bottom. And I'm going to add a vertical layout group to it where it will set everything to the middle center and control the width. I will save this. Now I want to create an empty game object. So I will create empty, and this will be called the width. Okay, now on the width, I want to add a UI TMP text message pro. This will be the title text. Oh yes, on the width as well, I do want to change the height to 150, give it a bit of generosity. Okay, now the title text, this will say WIDTH, and then colon. And I'm going to set the anchor preset Alt-Shift stretch to the left. And I'm going to give it a width of 300, a position of 0, and let's embolden, let's give it a maximum of 300, about 90. Okay, let's go with a font size of 90. And let's center it, have it to the left. Yes, that's all fine. Okay. Now we want a value text. This is the one that will be changed. So I'll just Control D. I want to give this a width of 100. Let's do 109 even. A position Y of 350. And it will have a value of 0, 0. Well, we set it to a value of 6 by default, I believe. Let's look back to our grid generator, and by default this value is going to be in our static game controller, not our grid generator. Okay, and yes, it will have a default value of 6. And for this value, let's have it in the center. Okay, I will call this not width text, or not title text, but width value text. Okay, and then finally let's add a width slider. So right click UI all the way here to slider, and this will be my width slider. Now for the width slider, I want to fill up the whole area, and then I will just drag it over. It's about 450-ish. I'm going to give it all the way to 500. Okay. And then I want to set a few values here. So the minimum value here is 20. The maximum value is 20. Set that again. It will go by whole numbers, so from 2 to 20 with whole numbers. Let's, on our canvas, we want to add our first script. We will add our static game controller. We can drag our width slider and our width value. We don't have the other ones, but we will add them later. On the width slider, when the value is changed, let's drag our canvas over, and it will do a static game controller on width change. Make sure you select the dynamic float on width change, otherwise it won't work. Okay, so that's our width. Let's duplicate it, and this will now be our height. Let's change all of our width stuff to height stuff. So height colon, I don't know, 88, 85, 80? Okay, size of 80. Let's change this title, height, and this title, height. Then this will have the game controller on height change. Back to our canvas, we can now drag our height slider into the slider and our height value into the value. Okay, save that. Let's create an empty game object, because this will be the random seed. Okay, for this, let's also give it a height of 150 and I will call it the rand seed holder. Okay, right click, add a UI image, and this will be the rand seed toggle. I will give it a color of red. It will be positioned to the middle left pivot point, 0, with a width of 150 and a height of 150. I will add a button, which I will add an onClick method, which will take the canvas and it will run the toggle random seed. There it is. Okay. After that, we want to add an input field. So I'll right click, add a UI input field text mesh pro, and this will be the rand seed input field. Let's stretch it. Let's drag it over 150, give it 200. Okay, let's say that the content type can only be integer numbers. I'm going to increase the width. Let's increase the font size to 105. I like that. I will also go into the placeholder and the text. I will give it the same color of, you know what, let's just do 70, 70, 70. That's treated me well so far. However, in the placeholder, it's going to take the default base room seed value of 42 for the placeholder. Sure, that's fine as well. You know what, maybe I can even make it like 50, 10, 10, 10. Okay. Then on value change with the random seed input field, let's drag the canvas into place. Static game controller, and we want the dynamic on random seed change. And save. So what this would do is it would change the random seed whenever someone types text into here. We need one more thing on our vert layout, so let's add an empty and let's say play button holder. Oh, we do need to drag these values into canvas, so go back to your canvas, and for our image we have the random seed toggle, and the random seed input field will be the random seed input field. Okay, now then let's right click and let's add a UI image, and let's call this the play button. For the play holder, I think I like it to be, oh, let's go 300. So let's give it a height of 300. For the play button, it will be, oh, let's go crazy, 500 by 300. Oh, even bigger, okay, 600. Perfect. I will right click. If you have icons, icons are perfect here, but I am not adding any extra graphics to this. Let's keep it at 70, 70, 70. Let's, okay, it's filled up. Auto size 300, emboldened, middle name PLAY. Okay, I think having it at like 240 is perfect. It will also have a, no, not the text, the play button itself will have a button which will take its own script. So let me add the scene loader to the game, to the play button. I will drag play button over here, and then scene loader script, it will load open scene. Okay, for the scene that it will open the Pathfinder scene, so I'll rename, copy that text exactly, and paste it in here. I will save it, and our back button is not actually functioning because we have nothing to go back to, so I'll turn that off for now. let me go File, Build Settings, and I will add the Setup scene to my current scene. This is true. This should be true no matter what platform you're building as. Okay, so now I have Setup scene in here, but if I want to load my Pathfinder scene, let's load that. Let's go to Pathfinder, let's go to File, and then Build Settings, and then Add Open Scene. Now it will add the Pathfinder scene as well. Okay, so that should all be set up. We are almost ready to start playing. We just have one last scene to set up, and we will be setting that up. Okay, so let's make our Pathfinder scene, and I do highly recommend that you do the steps that I tell you with the sizes that I give you, because if not, you will have to redo things like the input handler and the grid generator. Of course, I do recommend that you toy with the values and play with the functions so you can get your own things. So the first thing we want is we have our main camera, but let's go and add another camera to the scene. This camera I will call my game camera. I'm going to put it at 0, 0, 0 with a scale of 1, 1, 1, 0, 0, negative 10. For the flags, it's going to be a solid color, and I'm going to set it to 70, 70, 70. The culling mask will not be everything. In fact, we want to go to Layer, and we want to add a layer, and I'm going to add a layer called Grid. Let's go back to the game camera. Now I will select Nothing and then Grid, so it only has the grid. For our main camera, I'm going to have everything, but I will deselect Grid. Okay. In the game camera, we also need to remove the audio listener, otherwise you can receive an error about having too many listeners in the scene. Okay, let's go to target display as display 2, and we will add a few things later. Go back to my Pathfinder. Sure, we can actually add that right now. So I'm going to create a texture. So I'll right click and I want to add a render texture. The render texture I will call as game scene, and for this I will give it the size that I want, which is 1280 by 1280. Anti-aliasing is none, and everything else is default. But on my game camera, you can see here is my camera, and it is actually dependent on we can see the game camera here, and oddly enough it is dependent on the aspect of the screen, even though it shouldn't be. So I will grab my game scene texture and I will move it over to target texture. Okay, and we'll get back to that later. So next, let's add some top things. So I will right click, I will add a UI image, and I will call this the back button. So much like we did with our canvas in our other scene, I will say scale with screen size. The screen size is going to be 1800 by 3200 with an expand. Okay, and then on the back button, I'm going to anchor it to the top left, move it 50, negative 50, and and I will have the width of 300. I'm going to add a UI text mesh pro. I don't think I said this before, but make sure that you import the values if you do not have them imported already for the TMP text mesh pro. Otherwise, that will be why things are not displaying for you. Okay, 70, 70, 70, embolden, set to 300, look at what it is, 65, oh, it needs to say BACK. It also needs to be in the center. What about 70? Okay, we'll go with that. On the back button, we are going to go to our scripts, and we're going to add the scene loader script. We're going to add a button, and this button is going to take, oh, we don't want the, sorry, let's remove and remove, because this is adding it to our text. We want this on the button itself. Okay, scene loader, button. Add the back button, add the scene load script, and run the, and select the open scene. For the scene that we want to open on back, it would be the Pathfinder, so copy the name by clicking rename and then copying, and then paste it into the open scene. Okay, now that's the back button. Let's right click, add a UI text mesh pro, and this will be the title text. The title text I want to be 250 high, and let's add it to the top, move it down by -50, and let me give it a crazy width. Let's go with 700. Then I will set this to the center. It will have 300, it will be emboldened, and for example, it will say 5 by 5. And that will be the title for our scene. Then we want a mid bar, so I'll right click, I will create an empty, which I will call a mid bar. The mid bar will be stretched to the top. We will move it down -300, so it's right at the bottom of our title text, and let's move it 50 from the left, 50 from the right, and we'll give it a height of 150. Then on the mid bar, we just want 3 TMP text mesh pros. So add UI text mesh pro, and this will be the, sorry, we just want 2. So this will be the moves text. I myself have 3 because I have extra options in my main game, but of course we are just giving you a taste of it, so you can do something like adding it to, I actually had a nice fellow ask me to make a tutorial like this for him, so he can make a door lock with this, which I find wonderful, because I would have loved to have this back when I was testing. Okay, and for the test, for the word, this is going to say moves : 0. Okay, let's duplicate this, but instead of moves, this is going to be the connected text. We are going to stretch it to the right and give it a little bit more space. Let's give it a width of 750. Make sure the X is still 0, and instead of moves, it's going to say connected. And let's say 0 out of 25. Oh, wrong slash. There we go. 0 out of 25. Perfect. So that's kind of what it's going to look like. We do want both of them to be auto sizing. I usually don't use auto size, but we will here. Okay. And then we can add a game over scene. And so I'll right click the canvas, I will add a UI image, and this will be the game over image. I will fill up everything. I will give it a color of the same background. So 70, 70, 70, there we go. Feel free to give it whatever color you want as well. And then I will just give it a UI text. I'll be fairly lazy with this, so let me just increase the size. Okay, I think I like 0, 0, 700, 300, 700, 150. There we go. And this will say game over, middle emboldened. Increase the size. Okay, 100 is good. Let's actually change the anchor to the top, move it down -200. Now you have two options, so I'll add another UI text Mesh Pro. This will be reset. Duplicate. This will be quit. So this will say quit, and this will say reset. Width of 200, so let's give it a height of 100, width of 300. I think I like that more. Center, embolden, middle, increase the maximum, and a position of -400. Okay, let me copy the component 400, 300, 100. So 400, 300, 100, paste component values in QUIT. Okay, let's now select both of these. Let me add a component of a button, add the onClick method, and we'll actually take from the back button because we'll go to scene load script to open scene. Oh, no. Let me do this. Let me add my create empty, and I will call it the game controller. The game controller will have the script of game controller, and I do believe that this, while we're here, let's add the game over image as game over screen. Let's have the mid-bar move text, mid-bar connected text, and the level title as title text. Okay, now in the reset, we actually want that button to be connected to the game controller, because I believe the game controller is what has our new game function. Meanwhile, quit would go to our Pathfinder, and it would load our setup scene. So let me go back, let's go to quit, and let's go and let's paste that in. So let's save that. You know what, we can even go a bit crazier with this. Let's give it a width of 900, 1200, and 200. Increase the size even more. Wow, we're going crazy over here with the font of 190. Okay, let's turn off our game over image. That will just turn on game over. And that's the end of our, almost the end of our canvas. We want to add a game scene raw image. So let's go back, let's add a UI, make sure it's a raw image. The raw image we want to be size 1280, 1280, and I want to set it at the center top, but I will move it down -450 so it is right at the bottom of there. And for the texture, we will add the game scene, that the same thing we added to the camera. To there. Oh, make sure it's there. So this is the most important part. Make sure it's at 0, negative 450, 1280, 1280. Now if you change the Y 450 here, this is what you will need to change in the input handler height and width offset, yes. So the 450 is equal to the negative 1.59 offset. And if you see that your mouse is not clicking where you tell your mouse to click, it is because you need to change that offset. Now let's right click, let's create an empty, we will call this the grid. I will set my grid to exactly 0, 0, 0, and I'm going to add my grid generator. Oh, let's reselect the grid, and I will add the grid generator script to it. The instantiation location is going to be itself. The game camera is going to be it doesn't want the it wants the game camera. Whew. Oh. The game camera is going to be the game camera, not the cell prefab. For the cell prefab, I'm actually going to add some images. Now these images will be on my GitHub repository, so you can use them. Yes, I give you permission to use them in commercial games as well. And I ask that I will probably make a demand in the privacy policy and the license agreement that, if you use them, just mention me somewhere. And then I will add a folder for images. Okay, now let me open my images. Oh, no, not those images. I'll go picture, and I want to go to my Pathfinder game. There we go. So we have, no, we are only using the base, the border, the glow, and the mid. Okay, so I will drag those into my images folder. You will want to make sure that they are all Sprite 2D UI, single, tight, center, clamp, bilinear, stuff like that. Okay, so now let's start working on our cell prefab. So let me click on grid. I will move my mouse to the scene view, and I'll press the F key. This will zoom in onto it. Okay, so we have the grid here. What would this be? This would be the main camera. Yeah, so you can see right there that the main camera is changing while our game camera stays static. Oh, we do need to change make sure you're at game camera and projection to orthographic. That's why it wasn't changing before. Okay, but it must be orthographic. Okay, now on the grid, I'm going to right click, and I'm going to 2D object sprite square. This square I will call a cell. Instead of square, it's going to have the border image. Now this border image that I am giving you, I have found to be of the size 2.4, which is why in our grid we are using the, I believe that would be the grid generator. Let's see. Yes, we have 1.2 and then 2.4 later on for our cell size. We use it somewhere, maybe in our set images. Well, definitely in our set images, which would be down even farther. Yes, place images. Yes, so we have the cell size of 2.4 and the half cell size of 1.2. Okay. And yes, you can see that this is what it's like at 0, 0 in the very center of our grid. But if it's even, we would want it, pushed over. half of the cell size. To this as well, let's also add the cell script, and we want to create these things. We also want to add a box collider, make sure it's not 2D, and let's zoom in. Because we don't want the box collider to the edge, we want to drag it in a little bit. Now, I will give you the values that I use. I use 0, 0, 0, 2.3, 2.3, 0.2. So these are the values that I use, and I recommend using them as well. Okay. Now onto the cell, I will create a 2D object, sprite, and then a square. Now this square is going to have the image base, and that's all we need. And I will duplicate it, so 1, 2, 3. So for this I will call it the head. I know it's called base. This one I will call the glow, and I will add the glow here. This one I will call the prev bar, and I will add the mid image. And then this one I will call the post bar, which I will also add the mid image to. Okay, and then I will turn off all of these. I'll go to my cell. Let's drag the head where the head goes. Let's drag the glow where the glow goes, the previous bar where the previous bar goes, and the post bar where the post bar goes. Finally, we want to save, go back to Pathfinder. You know what, I hate having loose files like this, so I will call this the scenes. I will highlight these, I will drag these over to scenes. If it's just one, that's fine, but when it's multiple, I dislike it. Okay, delete that, because our cell prefab is all done, but that means we need to go back to our grid, and where it says cell prefab, we now drag the cell there. Make sure you drag the one from your assets and not your scene. You should delete the one in your scene because we no longer want to see that. We do want to add another thing. Let's go right click 3D object, and I will add a cube. My cube I will have at 0, 0, 0, and I will eventually turn off my mesh renderer, but I will have a box collider. But for my box collider, I want the size to be 0.01, 0.01, 0.01. So it's a very tiny box collider, just that big. And that's just big enough to hit my cells. But because of this, we also want to say it is a trigger. Make sure these are all 0, and we want to add a rigid body. With the rigid body, we want it with no gravity, and we want it to be kinematic. Okay, we can save that, and I will actually turn off my mesh renderer. If you want to see it, I definitely recommend, turning on the mesh renderer just so you can see it move around. Let's see. The cube as well, we need to change the layer. The layer will be on the grid layer. What about our cell? Yes, our cell as well. Click on the cell prefab and make sure it is also on the grid layer, and then say yes, change the children as well. If you don't have it on grid, then it will not display properly. Okay. And yeah, even our grid, let's make sure our grid is on grid, because the grid will parent the other items. Should be fine, but just in case. Okay, let me double check my settings. Yes. Now we want to add an empty input handler. And for our scripts, we will go input handler and add the input handler. So we have the main camera, the mouse tracking cube, and the cube again for the box collider thing. There's also an idea that I have of setting up a Boolean value to check if it should. But okay, hopefully this is the solution that fixes our problem and takes us off to Zion. Reset. Such a big relief. Okay. So let's finish this. Okay, that was a bit rough at the end, but everything is working as I want it to. Thank you for sticking in there with me. I'm wish that it went a little bit smoother near the end, but we got it to work in the end. I will have this code on GitHub. I will have this tutorial a bit edited on my YouTube, and I will even have some technical documentation to kind of walk you through it if you are not the video type. So thank you for watching. I hope that you enjoy this. I really hope that it's helped you out, maybe even taught you something. And yeah, if you like it, subscribe, watch my other videos, send me a message or a comment. I always enjoy those. And have a great day. Goodbye.